Hello, welcome to video one of topic 5.4. In this topic, we're going to define relative extrema, and we'll talk about how we can use the first derivative test to find relative extrema, which is really a procedure that we have already done in the previous section. And so if you watched and understood the videos for finding intervals of increasing, decreasing by using a sign chart, that's basically how we're going to use the first derivative test, or that's basically what the first derivative test is using the first derivative values to determine where relative extrema are. However, we kind of need to know what relative extrema is. So let's talk about some vocabulary here before we get started. Um, I guess the thing to remember is whenever they ask us for extrema, they're asking us for extreme values, right? Extrema is the plural form of extremum, and an extremum is an extreme point, like a maximum or a minimum. Those are extreme points, the highest point and the lowest point, right? So when we talk about extrema, we're looking for those highest, lowest points. But they come in two varieties, and I want to make sure that we understand the difference between both. And so when I talk about the absolute extrema, or absolute maximums and minimums, which technically I guess the plural would be maxima and minima. But when we talk about absolute, or some people call them global extrema, we're talking about values that have to be the highest value of a function. So if we have a function, and I'm reading here, if you'll read along with me, if I have a function defined on a closed interval, so if I know where I'm starting and I know where I'm ending, and I'm including those endpoints, and there's a c value in between those endpoints, I know that I have an absolute maximum value if f of c, the y value of that x value between a and b, is bigger than or equal to any x value in the closed interval, right? That kind of makes sense. An absolute means the very highest point on a window or interval of points. That means that y value or that function value has to be the biggest one out of all the, or biggest or equal to all the function values, right? It has to be the biggest one. Same thing for absolute minimum values. When I'm talking about an absolute minimum, I'm talking about a y value that's the lowest, that's the smallest out of all the y values in my closed interval. So some things that you should read into that definition. I have to be working with a closed interval, right? I have to have a beginning and an end, and I have to include those beginning and ending points. That's what a closed interval is. And when I'm looking for the absolute maximum, I'm looking for the point in that window of x values that's going to produce the biggest function value, the highest function value, the one that's greater than or equal to any of the other ones. And if I'm looking for the absolute minimum, well, then that would be the lowest. So how is that different from a relative or local extrema? Well, for those, we need to, I guess, understand how visualize some functions. So I'm just going to scroll this over here. Um, and so let's just visualize something. So let's say that I'm starting here at -5 and I'm ending over here at 7. And so I might have a graph that starts here and then it goes up and then it comes down and then it lands here. So I'm working on a closed interval between -5 and 7, right? So when we talk about absolute maximum, the absolute maximum would occur here. Whatever this y value is, this would be the absolute maximum. It is the highest y value of this graph. It is the highest function value within x equals -5 and x equals 7, right? Where does it occur? Well, I don't know. That's a question mark. But I know that I can see it. Same thing with the absolute min, right? This would be the absolute minimum value out of all of the points in this window from -5 to 7. This is, or maybe over here, this is the lowest point. So therefore, it is the absolute minimum. Where does it occur? I don't know, but I can see that it occurs there. I just need to figure out what that x value is. And that's kind of the process that we're going to go through. But if I have something that looks like this, we'll still do -5. We'll still do 7. We'll still start at the bottom. But this time we're going to go up, going to come down. We're going to go up, and then we're going to come down and end here. Do I still have an absolute max? Well, certainly I do, right here. This is an abs max. This is the highest point in this window. Do I have an abs min? I do. It's down here. This is the lowest point in this window. But I also have some other points that are of interest because they kind of create what I call hills and valleys, right? And so if I were to zoom in, and if I could zoom in enough, and I don't think I can, but if I could zoom in like right here, then I would notice that this point is a maximum in that neighborhood of points. And the same thing for this one, this is a minimum in that neighborhood of points. So I'm going to call this the relative max. So relative to the points around it, or in its local neighborhood, it is the highest point. Now, it's not the highest out of the whole thing, but in its little window of an open interval, we can see that it is the highest point. Same thing here. This would be a relative minimum because it is the lowest point out of this neighborhood. Now, is it the lowest point out of this graph? Well, no, the absolute minimum is over here in green, right? But this, within its little neighborhood of points, it is the lowest point. Now, some people would argue that this is also a relative min, and I would say it is a relative min. I'm sorry, relative max, because in this little neighborhood of points, if I create like a little window and zoom in, it is the tallest point. It is the highest point of that part of the graph. It happens to be the tallest point out of the whole defined graph, but it is also the highest point there. And so I kind of want you to see the difference between a relative max and relative min versus an absolute max and an absolute min. And so when I come back to Brian's definition here, he says, if there is an open interval containing C, so there's that x value, that special x value, on which f of C is a maximum, then f of C is a relative minimum. So that's kind of saying, hey, if I can zoom in and I can see that there's a point that's higher than the rest, even if it's not the highest out of all of them, but in that little open interval it is, then I'm going to say that it is a relative max. And the same thing with relative min. So he asks the question, so what does that mean in less technical math terms? Well, think of your height. So in our class, there is a tallest person, and in our class, there is a shortest person. That would be relative to our group. We have a relative minimum, the shortest person, could be me, and a relative maximum, could be somebody else, not me. But are they the tallest in our campus? Because maybe if we're talking of our function being the whole campus, then there might be a taller person than the tallest person in class, right? They would be the absolute maximum. Or there might be a shorter person than the shortest person in our class. That would be the absolute minimum. So I guess think of it in terms of perspective, right? If we're talking about a little group, then relative to the other people, we can have maxes and mins. But if we're talking about the whole group, that's why it's called a global extrema, the absolute maximum, the global maximum, then there has to be one tallest person or one shortest person. However, I do want to point something out. Could there be, when we measure everybody's heights, so I'm going to write here. I guess height would be the example that we could use. But if we take down everybody's height measurement, could there be that there's multiple people with the same tallest height, highest measurement? Could there be more than one person that's like, I don't know, 6'5"? I don't know what the tallest person on this campus is. And the answer is yes. So there could be two people that have the tallest height, but there is only one tallest height, right? It could occur with two different people, but there's still only one tallest height. So when we talk about absolute maximums and absolute minimums and relative maximums and relative minimums, we're talking about the output, the y value, the function value, It could occur at different x values, or in the case of the height, it could occur with different people, but there's still only one maximum height. And so, I guess bringing it back to what we've been talking about, the absolute minimum occurs for f of c as long as it's less than or equal all other values of all other values. I said it, I didn't write it. All other values of f of x, right? So there is this x value, which I'm calling c, that if I take f of c, f of that x value, the y value, it has to be less than or equal to all of the values, all of the other values on that function. Or if f of c is greater than all the other values of the function, then that would be the absolute maximum. But how are we going to define relative mins and maximums? We can say, oh yeah, we'll just look at a window, and if it's the highest point, then awesome. But there has to be a better way. And so we're going to say when f of x stops decreasing and begins to increase, right? If a function is going down and then it starts to go up, well, then this is the relative min. Similarly, if a function stops increasing and begins to decrease, then we know stops increasing and then begins to decreasing. Well, then there is the relative max point. And so in thinking of our relative extrema, our relative minimums and relative maximums in terms of increasing and decreasing, that's why we can kind of pair those two ideas and create what's called the first derivative test for relative extrema, which we're going to get into in the second video. But let's finish this part up. It says, can you label any points that are relative absolute maximums and or absolute relative and or absolute extrema? Okay. So let's start with the absolute points. Is there an absolute max? Yes. There's a highest point of this function which is defined from x equals -2 to x equals 11. This is, let me use a different color, this is the absolute max. So how would I write that? I would say the absolute max is 5 at x equals 11. What am I doing? I'm stressing the fact that the absolute maximum is a y value. It's an output. It's a function value. And that we can also tell where it occurs. So there's only one absolute max. There's only one highest point, one highest value, and the highest value is 5, and it occurs at 11. There's also an absolute min. So here's my absolute min. Absolute min is -1 at x equals 2. So now we know that there is a highest value, there's a lowest value. But in between, well, there's also some other peaks and valleys, right? Some hills and valleys that can be defined as relative extrema. So we're going to say this is a relative max. I can see that it peaks. It stops increasing, and then it starts to decrease. The relative max is 2 at x equals 5. I notice that there's a relative min here. So there's a relative minimum at x equals 7. Anything else? Is there any other point where the graph stops going in one direction and starts to go in another direction? Oh, right here. This is also a relative min is -1 at x equals 2. So this point is double labeled, right? It can be a relative min. If we zoom in enough, it's still a dip. And it's also the lowest point of the graph. It's the smallest y value, function value of the graph, and therefore it's the absolute min. Do I count this endpoint? Well, no, because it's never the highest or the lowest, and it certainly doesn't change directions around that point. Do I count this point? Well, no, because the graph continues to increase. It's just increasing at a different rate. And so I think I've identified and labeled all of my relative and absolute extrema. Remember, extrema, extreme points meaning maximums and minimums. And that's video one.